Now actually how RF communication happens. So this is very basic actually. Suppose some data, maybe audio, data and audio will be there. So data for internet surfing. This data will process and it will, some amplifier will be there, power amplifier, and it will go to through antenna, it will transmit. So for example, this is your mobile phone up to this. So it will, some antenna will be there. This antenna will communicate our base station, for example, otherwise it can come directly. Then in base station actually processing will be there, so it will communicate here. So base station antenna you can consider. So this is a basic RF communication path. So you can just send a signal and antenna will take care and he will transmit the signal. So in antenna, how it exact briefly means full discussion of antenna we can discuss later also. Now I am very interested to see the how NASA will send signal, how few crore kilometer, how he is sending. This one I am very interested to tell. So now coming to the picture. So NASA usually from Earth we send a signal, and for example a distance of Pluto, or maybe for example 15,000 kilometer. 15, we can make a distance of 15.2 crore kilometer also. For example, we are taking 15 crore kilometer. Now lot of thing will be there. 15 crore kilometer, it is not a joke. It is a very high distance, long distance, and there is a equation is there. The equation is how much power you can send, that is the transmitted power, that is called PT GT, some antenna receiver gain by 4 pi, that is on path loss formula is there, 4 pi lambda square. So this is called path loss. When you sending a signal from here to there, so there will be loss due to the EM signal. Suppose you are sending some signal, you are receiving some signal, so through medium it is going, it is not a conductor medium. So you are sending 5 volt here, you are getting 5 volt here, that is not the case, correct. So in this case path loss will come. So do you remember 15 crore, it is coming into the, sorry, some R square will become, sorry, some 4 pi R square, one R square term will be there. So if R increases, it is also inversely proportional and it is some square terms will be there. So if you transmit a PT power, then your path loss will be excessively high. So total path loss in this figure, then NASA have to send a few megawatt power. That much power it is impossible to share from here. Then what happened? Suppose there is a satellite they send here, how they will receive the data from here, because after path loss it will be very zero only. Then there is a two way, you have to increase your transmit power to reduce the path loss. So path loss is proportional to transmitted power by R square, some distance if we consider. So PT we can't increase infinitely, but R square you don't have choice. Now suppose some signal we sent and we got some signal we get back. Now there is a, how we sense the signal, this is called a receiver. One receiver will be there. So receiver, how much signal you will get, there is a ratio that is called signal by noise ratio. How much signal he got means from satellite, suppose we send a signal and this signal went here and he also responded and he also sent some signal, but this signal amplitude for example 1 volt, but when we receive this 1 volt signal will go to 1 picovolt. Pico means 10 to the power minus 12, means exceptionally a few crore down actually. Now it is extremely low voltage, so it is close to noise floor. What is noise? Noise is a unwanted signal, it causes without any source. So, a natural source based on earth, you can tell this is source of earth. So, noise also source of earth you can claim, because of some resistance, all the things, system resistance, also thermal, this is due to thermal resistance. So, electron spontaneous motion also, it will generate some lot of noise signal. So, this now whatever signal we received, and if we mix with noise floor, then that doesn't matter actually. if मीन्स नॉइज़ आपको ज़्यादा नॉइज़ हो गया, सिग्नल बहुत कम हो जाएगा, तब आप कुछ रिसीविंग जो पावर है कुछ मिलेगा नहीं एक्चुअली. तो इसको जब हम एम्पलीफाई करेंगे, जब वो फ्रीक्वेंसी जब 1 पिकोवोल्ट आया है, 1 पिकोवोल्ट को हम एम्पलीफाई करके 1 वोल्ट जब करेंगे, बहुत एम्पलीफायर यूज़ करके, तब नॉइज़ भी एम्पलीफाई होने लगेगा. तो लॉन्ग डिस्टेंस के लिए हम लोग हाई पावर तो अप्लाई नहीं कर सकते, वी विल गिव मॉडरेट पावर एज ए ट्रांसमिटेड पावर, बट इन रिसीवर सेक्शन वी विल वर्क ऑन इट. We will develop our receiver in such a way, at least from few crore kilometer, if any signal come also, we will detect the signal. So, we will have a choice of receiver. So, now I am taking example of NASA. So, from few kilometer they have to use the receiver in such a way, the small, very small signal also can be easily distinguishable. Now, signal to noise ratio we have to maintain, at least signal will be higher. Now, how noise will be reduced? There is a big question. There is a formula, noise is equal to KTB. Now, K is a constant, Boltzmann constant, T is a temperature in Kelvin, B is some bandwidth. How much signal you are getting, that is the bandwidth. Sometime to reach higher data rate we use a high bandwidth. Now, to receive a signal, very small signal itself, then we will amplify to higher amount. The amplifier full control we have, we can increase any signal, any amplitude also. So, 1 picovolt signal also we can amplify, 1 watt also, 1 kilowatt also. So, there will be no issue, but we have to reduce this, remove this term first. How we will remove? So, it is not an easy job. So, this T is a, if anyhow this T, if I make 0 Kelvin, then what happened? N will be 0. So, total noise will be 0. Then how, what is this noise actually? So, receiver means, suppose you design a system in your home only, suppose for example NASA. So, NASA laboratory they will make a receiver, and in that receiver they will make an environment such that temperature will be 0 Kelvin, but ideally 0 Kelvin may not possible. So, some cooling mechanism is there, superconducting technique is there. So, nitrogen cooling, helium cooling. So, nitrogen cooling can give 4 Kelvin. I am not 4 Kelvin. Liquid nitrogen also give 77 Kelvin. I have to show it. Anyway, so if we reduce the temperature a very low region, our receiver system, if we reduce the low temperature, there is a chance of low noise. So, in that case, we usually use in spacecraft all the things, we use very cryogenic things. So, temperature will be very low. Recently, NASA sent Webb telescope, there are also several cover they put over the sun to make the system as cool as possible to reduce the noise. If the noise is increased too much, total receiver will gun. So, huge distance we do not have a choice of high power, but we can receive the small signal at least. So, this is called a detector system, radio spectrum system, spectrometer system. So, that is all about the receiving communication system. Now, I am coming another thing. Suppose NASA or ISRO also, if you send some satellite, and we have to usually communicate the satellite frequently, because and time of सेंड द सिग्नल, जब हम सैटेलाइट भेजेंगे तब भी कम्युनिकेट करना पड़ता है. तो जो पूरा सिग्नल यहाँ पे कंट्रोल करके उसको देना पड़ता है हर टाइम. But 15 crore kilometer, it is not a small distance. If you check the light also, it will take some time. So when NASA, I am taking again example, when send some signal, the speed of the light will the EM wave light speed. EM wave, electromagnetic wave also, it can't go beyond the light speed. So long distance communication, first you send a signal, this signal will come back to a receiver, इसमें time लगेगा. For example, from record I am telling, when NASA or ISRO send some satellite in long distance, it will take 10 to 15 minutes to respond the system. So suppose we take a photo from Mars, for example ISRO. Now nice photo they took. Now how to send the data? 1 Mbps. 1 Mbps it will take 1 hour to collect the data, 1 hour or 1 day. So another issue is the distance between the transmitter and receiver to get the data. So now there is a solution. This solution is not very bad but not very good, not also good also, but you see in between on solution is there. So we will use high frequency bandwidth. So for mobile phone 960 megahertz to, for example, 1000 megahertz. So it is taking 40 megahertz. Now 3G, 4G 3.3 to 4, so 700 megahertz. Now these megahertz, B is 700 megahertz. If we send a signal and their data speed is very high distance also, and data, if you check the bandwidth everything, if we increase the high frequency, bandwidth will be huge. C proportional to bandwidth, channel capacity. When long distance communication, then C channel capacity is equal to B into log to 1 plus SNR. This is the formula. So those are RF people also. I am trying to give more elaborately to the fact with one equation, because equation is fundamental, at least some idea we will get from this. So signal to noise ratio is exceptionally bad when it is coming from far distance. Only we have a control of bandwidth. Now if you are going a fighter, you are going to fight with 40 megahertz bandwidth, it is only failure. Then what we will do? We will increase the bandwidth. Let's take 1 terahertz bandwidth. 1 terahertz means 10 to the power 12 bandwidth I am giving. 10 to the power 12 hertz. 440 megahertz is 40 into 10 to the power 6. So 10 to the power 12 and 40 into 10 to the power 6. So huge difference will be there. So 1 terahertz is equal to 1000 gigahertz. Gigahertz means 10 to the another 1000. This is this much, 10 to the 1 lakh megahertz. So instead of 40 megahertz, I am giving 1 lakh megahertz. So now this channel capacity, long distance communication, we have to go terahertz. So NASA, whatever NASA, ISRO, whatever the design they are doing, space application, so all about high frequency, because without high frequency we can't deal this small, very this signal to noise ratio is exceptionally less. So again this noise they will take care, the RF engineer will take care of noise. So that's all about the how communication will happen. This is the basic fundamental. If you want to know anything, small idea, anything, small thing, if you want to know, please let me know. I will be very happy to answer. आपको कुछ भी छोटा की जानकारी चाहिए आप भेज दीजिए, मैं ट्राई करूँगा. और चैनल को प्लीज़ सब्सक्राइब कीजिए और आप शेयर कीजिए और लाइक कर दीजिए. That's all for now.